Hello, in this video we're going to be talking about depreciation. So depreciation is about the value of things over time. We know that all things lose value over time. We often talk about cars, and we all know that as soon as you drive off the lot, the car loses value. And we have two types of depreciation. One is called straight line. Straight line means that the thing, whatever it may be, loses an equal amount of value each year. So if it's initially worth $6,000 and it has a 3-year lifespan, it's going to lose $2,000 per year down to zero. We use straight line depreciation when something has absolutely no value, it is completely useless. Throw it in the trash when you are done with it. Although we do have items like that in Parks and Recreation, they tend to be more on the smaller side and things we wouldn't necessarily depreciate for accounting purposes anyway. However, the other type of depreciation we do more commonly use, and that is declining balance. Declining balance means that although something's going down, it never completely loses value. So think about a car being the classic example. The balance is always going down, it's always depreciating, but it never quite hits zero. You may be done with it, it may be junk, it may not drive anymore, but you can sell it for parts, you can donate it. There's always things you can do with that. The formula is fairly simple, and I'm just going to walk you through that, through a problem. So here's our example. You are the transportation manager for a large luxury hotel. You have a fleet of Lexus cars that you use to pick up and transport special guests. You want to make sure that you always have relatively new cars, so you do not want to keep the cars for more than 5 years. Your boss asks you what the car's value will be at the end of 5 years. Assuming an initial purchase price of $80,000 and a depreciation rate of 116%, what will the value of the cars be at the end of 5 years? So let's just put in a little table, everything we know, year, lifespan, our depreciation rate, and you'll always be given that number. And then that's going to, from that we're going to be able to calculate a depreciation amount. And then I left off one thing here. I'm going to slide this over. Right, which is the starting amount. Okay, so 5 years, so year 1, 2, 3, 4, 5. So we're saying this after year 1, after year 2, after year 3. We start with an $80,000 car. Let's format these. Okay, we know it has a lifespan of 5 years. Depreciation rate of 116%, so we're going to put that as decimal 1.16. Okay, now we want to know in year 1 how much does it depreciate. Again, very simple formula, equals the amount divided by the lifespan times the depreciation rate. Okay, we get to 18,560. What this is telling us is that after the first year, it declines in value a little over $18,000. Okay, so now this is our new starting amount. Again, rather than retype the number, I'm going to reference the cell. So equals this amount. Okay. Now, the beauty in here in Excel, we can keep writing this, and actually I'll write one more just to show you. So lifespan is always 5. We're always dividing by the total lifespan, not just the remaining lifespan, the total lifespan. Okay, rate is 1.16. Okay, we know from past I can just copy paste this down, so I'm going to do that. Okay, so this time it loses. Did not do something right? Oh, I sure didn't do something right. So it depreciated $18,000, so now I forgot to subtract that from the original amount. So 80 minus 18,560. There we go. Sometimes we make mistakes, but hopefully you let your logic catch you and go, that doesn't look right. Because it's easy to make simple mistakes sometimes. So in the second year, it depreciates another $14,000. And I could keep rewriting these formulas down. But we're going to go back to some copy and paste and some Excel anchors. Okay, so this we know it's always going to be the cell above it minus the depreciation amount. So it's that, C20 in this case minus F20. So we just pull that down. Okay, and I can get that all the way through. Okay, And I could take the lifespan and pull it down. I could take the depreciation rate and pull it down. The reality is we know those are always going to be the same. So here we can use anchors. So, and we'll just do it off 21. We can do it off 20. Actually, why don't we just do it off 20? That's what we normally do. So we know the lifespan is going to stay the same. So I put in the $, which is an anchor, which means never change that Excel. And we know the rate is going to be the same. So I anchor that. And then I pull it down. Okay. And then really, so that's after 5 years. So one more cell there. So after 5 years, we have a value of $21,000, depreciated by that amount each year. You can see it, as we know with the car, it's a huge drop when you drive it off the lot, and it kind of slowly levels out from there. So that's our depreciation. Let me know if you have any questions.